Today we're going to be doing solving linear systems algebraically. So previously we learned about how to solve systems by graphing the equations. Today we're going to learn two new methods, and they are both algebraic means. It's substitution and elimination. Both of these ideas you saw or were exposed to in Algebra 1. So I'm not going to go super in depth. I'm going to do a quick review of how to do each of them and hit some deeper meaning stuff as well. Our first example is solve the system. Gives us two equations, 2x plus 5y equals negative 5, and 3y equals 3 minus x. So the first method we're going to do here is substitution. Substitution, I would say, is probably my least favorite option of the two. I think it's a little bit more tedious, but this is usually the method that most people like to start off with. So we have steps for substitution. There's going to be 4 steps in total. The first step is to solve an equation for either x or y. It doesn't matter which variable you solve for. I always try to find one that is easiest to solve for, will be less time consuming to solve for. So if we look up here, you're going to pick out which thing you think would be easiest to find, and then which variable you want to do. So I'm looking at this, and I'm kind of leaning towards this second equation there. This 3y equals 3 minus x. The reason being, you have an x that doesn't have a coefficient at all, so it'd be really easy to follow. You won't have to divide, and it'd be a pretty quick transition to actually solve for it. So what we're going to do is we're going to take that equation and we're going to solve for x. So we have 3y equals 3 minus x. I'm going to subtract that 3 equals negative x. Divide by negative 1, and I get negative 3y plus 3 equals x. All right, so I've gotten my x, I got what x equals, we're good to go. You can also write that the other way, like x equals negative 3y plus 3, doesn't matter. So step 1, solve for a variable, doesn't matter which one. All right, step 2, you're going to substitute that value into the other equation. Okay, so we got this from that second equation. So we're going to take that first equation, the 2x plus 5y equals negative 5. And instead of that x value, we're going to plug in what we just solved for. So we have 2 times x, which is now negative 3y plus 3 plus 5y equals, whoops, sorry guys, my dog just bumped into me, negative 5. All right, so we plugged it in there. Step 3 is you're going to solve this. Okay, so I get negative 6y plus 6 plus 5y equals negative 5. With combined like terms, negative y plus 6 equals negative 5. Subtract that 6, negative y equals negative 11. Divide by negative 1, you get y equals 11. So now we have successfully solved for one of the variables. We have to now find the other one. So how you do that is you're going to plug that value into one of the original equations. It doesn't matter which one you want to do. They're going to get you the same result either way. So here are our original equations. I'm just going to pick the first one, that 2x plus 5y equals negative 5. So I have 2x plus 5y. We now know that y is 11 equals negative 5. 2x plus 55 equals negative 5. Subtract the 55 over and divide by 2. I get that x is negative 30. So that means my solution is negative 30, comma 11. All right, so that is substitution. So 4 steps to do that. The second method that is algebraic is elimination. This is my personal favorite. It is kind of matching this up, and it's, I think, a little bit more self-sufficient and a little bit quicker. The system here is 3x minus 7y minus 10 equals 0, and 6x minus 8y equals 8. So like this, we have steps here. This is a 4-step method as well. This one, the first step is going to line up the variables. And what I mean by that is when you look at the equation, I want all the x's to be in the same spot, the y's, and then the numbers. So when I line them up, I'm going to keep the first one kind of the similar. I can say it's 3x. I just put my x's first, then my y's, then my equal. I move any numbers to the other side. So my second equation is good to go. Okay, so again, like I said, I always do the same pattern, x, then y equals, and then the constants. All right, that's step 1. Step 2 is to get one of them equal. But have it be the opposite number of a variable. So this is what I mean by this. When you're looking at this, you're going to try to make either the x's or the y's have the exact same coefficient out in front. All right, you just want them to be opposite numbers. So if one of them is a positive, you want the other one to be a negative. So for example, if we look at our coefficients here, I've got, change this up here. I've got 3 and 6, -7 and -8. So our goal is to take those and we're going to try to match them up. So I'm looking at here, I'm thinking, well, 3 and 6, there's an easy way that I can make those both be the same number. I can take that top equation there, all right, and I can multiply it by 2, and that would give me the same number. It'd both be 6 and 6 then. Now they want it to be opposite, which means it wants to be the opposite sign. So if this original one is positive, we want to make this negative. So what I'm going to do is I'm going to take that top equation, I'm going to multiply it by -2. Take that top equation. I'm going to multiply it by -2. So what that would give me is -6x plus 14y equals -20. I'm not going to change that second equation, so it's going to be 6x minus 8y equals 8. Okay, so again, if you notice now, our x's, they have the same number, they're just opposite signs. Now that you have that accomplished, we're going to add the equations together. We're going to add these together. So you're going to add like terms. So up first we have -6x plus 6x. Well, that reduces down, cancels to 0. Then we have 14y minus 8y. That gets me 6y. And then we have -20 plus 8, which gives me -12. And the great thing about this is we have one variable and we can quickly solve. If I divide by 6 on both sides, I get y equals -2. So we have one of our variables. Once you have one, you just need to plug it into one of the original equations. All right, so I'm just going to plug it into the first one again. So the first one is -3x minus 7y minus 10. So we have 3x minus 7 times your y, which is -2, minus 10 equals 0. I have 3x plus 14 minus 10 equals 0. 3x plus 4 equals 0. Subtract that 4, and then divide by 3. So my final solution here is -4/3, -2. All right, so elimination, it can be as simple as just multiplying one equation. You can also multiply both equations by a number. I try to find it when it's a little bit kind of streamlined, just multiply by 1. Some other things I want to kind of talk about or address. We think about what situation or how do we know when the answer is no solution and when the answer is infinitely many. So I want you to go back to when we were in our last unit about solving equations. We talked about when we got to no solution. So usually that's when we were doing our equation and the x's canceled out and you were left with some type of an equation. Usually that equation is going to be a false equation. So something like 0 equals -10. That is not a true statement. That's a false statement. So that would result in a no solution. Whereas an answer is infinitely many is when you solve and you get rid of those variables, all right, and it's a true statement. such as 3 equals 3. All right, and that would be infinitely many then. Let's do one more example together. All right, this example says solve the system. All right, so when we're looking at this system, we have to figure out what we think would be the easiest. For me, I'm going to reorder them or line them up like we did in elimination just to kind of visually see. It may help us kind of figure some things out. So I'm going to reline them up. So I've got 6x plus 15y equals negative 12, negative 2x minus 5y equals 9. All right, so I'm looking at this. I'm thinking of substitution. I don't think I would do substitution. Reason being, I don't see a variable completely by itself. And I think it'd be a little bit messy to kind of solve for one of those variables. So I'm going to do elimination. And I'm looking at here, and it's kind of easy. I can do either x or y. It doesn't matter in this instance. If I was going to get the x's to match up, so I want it to be 6x, and I want this to ideally be negative 6x, all I would have to do is multiply that whole thing right there by 3. So the top would remain the same. And the bottom would become negative 6x minus 15y equals 27. Now that one of the variables cancels out there, I'm going to add them up. 6x minus 6x would just be nothing, go to 0. 15y minus 15y would also go to 0. So this whole side is 0 equals. Over here we have negative 12 plus 27, which would give me 15. So we have a situation where all of our variables canceled out, and we're left with just 0 equals 15. You can think, is that a true or false solution there? This is definitely a false one. All right, so when it's a false one, it's going to be what we say no solution. Oops. No